Welcome to the Keyring and Certificate Security 200 course. This course will cover how ACF2, Top Secret, and RACF authorization checks are performed to access key rings and certificate private keys. After this video, you will be able to recognize how authorization checks are done for both access to key rings and access to certificate private keys, and understand how administration security works with key rings and certificates. Whenever a ZOS client or server task accesses a key ring, there is a resource check performed. These SSL/TLS application tasks make a USSR_data line call to request a key ring and certificates. The External Security Manager, or ESM, will validate access to the key ring. Two resource checks are performed. If the first check fails, the second check is also performed. The first check is known as a ring-specific profile check, where the resource name consists of the ring owner and the ring name followed by the characters LST for the resource class RDataLib. Read access is required to access the key ring. For ACF2 rules, the RDataLib class defaults to a type code of RDA. Ring-specific profile checking allows user access to a single key ring. If the first check fails, the next check that is done is known as a global profile checking, where the resource name is the string irr.digtcert.listRing for the resource class facility. For ACF2 rules, the facility class defaults to a type code of FAC. Read access to this resource is required to access a key ring that is owned by the client or server task's user ID. Update access is required for access to a key ring owned by another user's user ID. Global profile checking allows the user access to all key rings defined in the ESM database. Once again, global profile checking is not done if the ring-specific profile check is allowed. For key ring ownership, here we see that the both key ring owner FTPD and ring name FTPD ring name is specified when the key ring is created. Here are sample ACF2 commands that can be used to create the rules for access to a key ring. First is the ring-specific profile checking rule for the resource, RDataLib class. The next two rule samples are for the global profile check. First, the rule for the facility resource class for a key ring owned by the task's user ID, and second, the rule for when the task's user ID does not own the key ring. Here are the sample equivalent top secret commands for the RDataLib and facility resource class permits. Here are the sample equivalent RACF commands for the RDataLib and facility resource class permits. Next, we will cover the requirements and resource checks for access to the private key of a personal or site certificate. In order for a certificate's private key to be accessed, the certificate must be connected to the key ring with a usage of personal. One of the following preconditions must be met. First, if the user ID of the task that is accessing the certificate is the owner of the certificate, then access to the private key will be allowed. Second, if the user ID of the task accessing the certificate has update access to the resource ring owner.ringname.lst for the RDataLib resource class, then access to the private key will be allowed. Finally, if the certificate is a site cert certificate and the user ID of the task that is accessing the certificate has delete or control access to the resource, irr.digtcert.gencert for the facility resource class, then access to the private key will be allowed. The next few ESN-specific slides will show how certificate ownership is determined and provide sample rules and permits. Here is an ACF2 example of how certificate ownership is determined, as well as sample resource rules that allow access to the private key of a certificate not owned by the user ID FTPD and a sample rule for access to the private key of a site cert certificate. Note the type RDA rule for the RDataLib resource check for access to the private key of a certificate not owned by user ID FTPD and the type FAC rule for the facility resource check for access to the private key of a site cert certificate. Here is a top secret example of how certificate ownership is determined and a sample top secret equivalent commands. Here is a RACF example of how certificate ownership is determined and a sample RACF equivalent commands. The three ZOS ESMs ensure that only authorized users can access digital certificate commands, certificates, key rings, and token objects. Each ESM has special privileges that allow users the authority to administer security, including key ring and certificate administration. ACF2 has the security privilege Top Secret has the MSCA or SCA security level, and RACF has the special attribute. Each of the ZOS ESMs allow for more granular control over keyring and certificate administration by allowing users access to commands specific to keyrings and certificates. ACF2 utilizes a resource class of CASEC-AUD, which is mapped to a type code of AUD, with a resource name of acfcmd.user.cmd, where CMD is the specific keyring or certificate command. Top Secret also utilizes a resource class of CASEC-AUD, with a resource name of tsscmd.user.cmd, where CMD is the specific keyring or certificate command. RACF utilizes a resource class of facility, with a resource name of irr.digtcert.function, where function is the specific keyring or certificate command or function. For all three ESMs, the access for these resources varies based on ownership of the keyring or certificate, as well as the specific command or function. This video showed you how to recognize how authorization checks are done for both access to keyrings and access to certificate private keys, and understand how administration security works with keyrings and certificates.